Hello Shanghai Blockchain Week. Thank you so much for having me. I'm Dominic Williams. I'm the founder and chief scientist of the Divinity Foundation that is working to bring about the Internet Computer. Today I'm going to introduce the Internet Computer in about 15 minutes. This is a really big deal for me. I'm so excited to be here because I was last here in 2016, almost 4 years ago, talking about the Internet Computer Project in Divinity. Back then we didn't have any funding and really it was just an idea. And I stand before you today, almost 4 years later, running the biggest R&D organization in the industry with research centers around the world and approximately 120 team members. Okay, so what is the Internet Computer? Well, the Internet Computer is the third major innovation in blockchain. The first was Bitcoin in 2009, which provided a simple ledger for cryptocurrency. The second was Ethereum, that made cryptocurrency programmable with Turing-complete scripts. The Internet Computer takes all that much further and introduces a blockchain that has web speed and can scale its capacity without bound, in principle, to host all of humanity's software and data. The Internet Computer is created by the ICP protocol. ICP stands for Internet Computer Protocol. And ICP runs over the internet to combine compute capacity from independent data centers around the world and create the Internet Computer in cyberspace. The Internet Computer hosts WebAssembly canisters. WebAssembly canisters are an evolution of smart contracts. They're kind of secure code units with data. The Internet Computer can host a limitless quantity of canisters and canister data. And that's one of the many reasons it's revolutionary. Another reason it's revolutionary is user software such as a web browser or an app on a phone can interact with canisters directly. There are no intermediaries. And that makes the Internet Computer very different to a traditional blockchain like Ethereum, where you need to run a website from a server or from a cloud service like Amazon Web Services to create an interface. The Internet Computer provides an end-to-end solution. And you can build anything on the Internet Computer. You can build websites, you can build enterprise systems, like an HR system or an inventory planning system. You can build open internet services, and they can be hyperscale internet services. You can build pan-industry platforms. And of course, you can build things like dApps, DeFi, just like you can on traditional blockchains. So what's incredible with this system is there are no dependencies with legacy IT. You don't need big techs, cloud services, you don't need server machines, you don't need databases, you don't need firewalls, you don't need web servers, you don't need CDNs, or anything else that you use today when building a system. The Internet Computer alone is enough. You can write code and push it to the Internet Computer to create things like enterprise systems and internet services. The Internet Computer provides one secure, unstoppable, seamless universe for software and data. Within that universe, systems can interact with each other at zero cost. But systems can keep their data private. And that again is very different to a traditional blockchain. So you could use the internet computer to build open versions of internet services such as Uber, LinkedIn, eBay, WhatsApp, and Salesforce. You could run an enterprise system. And that enterprise system might interact with some of these open internet services. You could build a website, you could build DeFi. You could build a pan-industry platform. A great example of a pan-industry platform being built on the internet computer today is Origin in Switzerland, which is supported by major Swiss watch manufacturers and will provide a means of provenance, tracking, among other things. So today, developers can start building using either Motoko or Rust languages. And if you're a developer and you want to write code that scales, go to sdk.dfinity.org and get started. At Dfinity, we've also been building some sample apps, and one of these is called CanCan. CanCan works very similarly to TikTok. It allows users to upload videos, short videos to their account, and share them with other users, which they can make searchable. And of course, there's video stream. What's incredible is that the internet computer is a blockchain that's capable of handling exabytes of user video and storing it on-chain and streaming it to users and making potentially billions of items of content searchable. And it enables developers to create dApps like this very simply. It makes it easier than building something like TikTok on legacy IT. Sailfish is a system currently being developed by one of the community members, and it shows how DeFi is going to be possible on the internet computer, which makes it possible to run decentralized financial exchanges on-chain. So it runs at web speed and can scale its capacity. So the question is, what will China build? I think today the world is very aware that China has a huge and growing pool of talent. Those developers also have incredible expertise in dApps and social media, and new token-based funding models will make it much easier for them to get funded. And of course, the Internet Computer Project has a history in China, and Wanxiang and Deng have been long supporters. So let's talk a little bit more about how this Internet computer gets created. We know that the ICP protocol runs over the internet and combines compute capacity from independent data centers around the world. These independent data centers run special node machines. And in fact, they will run many node machines. Eventually, there'll be millions and millions of these node machines in data centers around the world. There are already hundreds, and the public network hasn't yet launched. What's interesting is the network might be called an evolution of proof of work, because the ICP protocol rewards data centers per compute node that they run. The difference, of course, is these compute nodes are doing useful computation, not pointless hashing. So, as I mentioned, ICP is an advanced blockchain protocol. And it has a master blockchain, which hosts something called the network nervous system, sometimes abbreviated NNS. This network nervous system actually has a public key. In fact, the public key comes from the chain, and it exists courtesy of something called chain key technology. And this makes it possible for software to validate interactions with the network nervous system just by checking communications assigned in a way that corresponds to its public key. So this is a huge, enormous step forward in blockchain science. It means that internet computer blockchains can be validated just by their public chain key. And they don't actually have to keep all the locks at all. So think about this. You can validate interactions with an internet computer blockchain with a 48-byte chain key. By comparison, with a traditional blockchain like Ethereum, you have to download all the previous blocks. By the end of this year, the Ethereum blockchain nodes will have to contain almost 5,000 billion bytes of hash blocks. That's about 5 terabytes. So we're going from needing 5 terabytes of block data to validate the Ethereum blockchain to needing just 48 bytes. It's a huge advance. So the network nervous system increases capacity by creating new blockchains, which are called subnets in the Internet Computer Project. The network nervous system creates new blockchain subnets by combining nodes at independent data centers around the world. And this is how it can guarantee the security of the blockchains it creates. And it creates as many blockchains as it needs with respect to capacity demands. And each additional blockchain, subnet, hosts more canisters. What's so cool is that these different blockchains are enabled to communicate directly with each other by chain key technology. And this essentially is how we get unbounded scaling of computation and data storage on a blockchain. And this, of course, is why DFINIT is called DFINIT. It's a shortening of decentralized infinity. So those of you who don't run data centers might be interested in other ways of participating in the operation of the network. The easiest way to do this is to participate in governance, for which you can earn ICP tokens. ICP was previously called DFN. So to do this, you take your ICP tokens and you lock them in something called a neuron. And when your neuron votes, the network nervous system pays you voting rewards in the form of more ICP. Obviously, the more ICP tokens you lock up, the greater the voting power and the voting rewards. But you can juice this in other ways too. So, for example, the longer you lock your tokens up, the greater the voting power and voting rewards. Every day, the network nervous system processes hundreds of proposals of different kinds. But you can configure your neuron to vote automatically by following other neurons and help the internet computer network by increasing the security and participating in networks. So we've just passed the fourth of 5 big public milestones. The first was copper, passed it in November last year. The second was bronze. That occurred in Davos this January. Then came tungsten at the beginning of the summer, when we bootstrapped a development network. And the latest is sodium. And sodium introduces some network economics. The final milestone is coming later this year and involves the sodium network becoming the public network. And that's working end of this year. So, I'd like to invite you all to start building on the internet computer, start building on the sodium network. Please go to dfinity.org/sodium or to sdk.dfinity.org. Download the SDK and experience what it's like building an internet service or DeFi or an enterprise system using internet computer canister technology. So, thank you very much for listening. Hope you enjoy. Bye-bye.